Your lesson today is lesson 8, and we're going to be talking about proportional relationship again in regards to equations. Your objective today, I will demonstrate my mathematical ability to use the constant of proportionality to represent proportional relationships by equations in real world context as they relate the equations to a corresponding ratio table and or graphical representation through class discussion. This is probably going to be one of the more challenging lessons that we've had, so bear with me as we go through it. If you have questions, you know what to do. Okay, a couple things to remember, just some review points that I want to make sure you guys understand. First, that proportional relationships, they must have a constant ratio or a unit rate. If they don't, they're not proportional. And the next thing you need to remember is that the constant ratio or unit rate can also be called the constant of proportionality. We talked about this yesterday. Okay, and I know I have some grammatical errors, but just bear with me. Alright? So the biggest thing you need to understand is that when I start talking about the constant of proportionality, I'm talking about the unit rate and I'm talking about the constant of proportionality. Alright? Let's look at the first problem that we're going to be dealing with. Okay, so this first problem is dealing with gas. And, you know, the question is, are we going to have enough gas to make it to the next gas station? If we look at the problem, it says your mother has accelerated onto the interstate beginning a long road trip. And you notice that the low fuel light is on, indicating that there's a half a gallon of gas left in the gas tank. The nearest gas station is 26 miles away. Your mother keeps a log where she records the mileage and the number of gallons she purchased each time she fills a tank. You use the information in the table to determine whether you will make it to the gas station before the gas runs out. You know that if you cannot make it, that you know if you can determine the amount of gas that she consumes in a particular number of miles, then you can be able to determine whether you can make it to the gas station or not. Okay? Well, the first thing that I would do, if it was me, is I'd look at my table and I'd want to know what my constant proportionality is for each of these. So if I look, I go 224 divided by 8. That's going to equal 28. Okay? If I go 210, or rather, not 210, 280 divided by 10, that equals 28. And if I go 112 divided by 4, that equals 28. So my constant here, my constant proportionality is 28. What does that mean? That means that for every 1 gallon of gas, the car is going to drive 28 miles per gallon. Okay? Now, I want to write my equation. And a couple things you need to remember. When I'm talking about the equation, is y equals kx. Now, we know that x and y are variables, and we know that k stands for the constant proportionality. But what does k equal? K then equals y over x, and we'll talk more about this in a minute. So if I make gallons my x and miles driven my y, I'm going to have, that's how I found my constant, because I went 224 divided by 8, 280 divided by 10, 112 divided by 4. Okay? So if I write my equation, I have y equals 28x. Now, I can use these letters as my variables if I want to. So miles would equal 28 times the number of gallons. Alright? Now, knowing that there is only a half a gallon of gas left when the light comes on, I need to know, was she going to be able to make it? You know, looking at this, she's probably not going to be able to make it because she only gets 28 miles to 1 gallon. And if we look, since we only know a half a gallon is left, that means she can only travel 14 miles. And we know from the problem that the local gas station, the next gas station, is 26 miles away. So she's not going to do that. Okay? Now, another question I have is, using the equation that we found. So either one of these two equations, it doesn't matter which one you use. Okay, they're both the same thing. The only difference here is the variables. Now, using the equation, how far can her mother travel on 18 gallons of gas? And I want this solved in two different ways. Okay, way number one is going to be very, very easy, because all I have to do is take 28, which is my constant, times the number of miles I want to go, which is 18. When I multiply that together, I'm going to get 504. Okay. The second way is if I use the equation, and I'm going to use the equation to my right out as m equals 28g, and I'm going to go m equals 28 times 18. From before, that's 504 equals m. Okay, so your mother, or the mother, can travel 504 miles with 18 gallons of gas. Alright, now I have one more question. Using the same concept, I want to know now how many gallons of gas will she need if this trip is going to take us 750 miles. Okay, there again so we're going 750 miles. Let's go back over here. 750 miles. And I want this solved in two different ways. Okay, so way number one, I'm simply going to go 750. I have to write my numbers right. Okay, 750 divided by 28. And that's going to equal 26.8. Okay. The other way, the second way, number two, is to use my equation. So m is 750, so 750 equals 28g. How do I get g by itself? This should be reviewed from last year. To isolate the variable, I'm going to divide by my constant. So I'm going to divide by 28, and g equals still 26.8. Okay, so it would need 26.8 gallons would be needed to drive 750 miles. Alright? Okay, I just want to remind you of a couple things. Number one, our equation that we're going to be dealing with is y equals kx. And k equals y divided by x. Now, when we're writing equations, okay, it's really important that the one is going to depend on the other. So we have the independent let me spell it right, independent, and I have the dependent. Okay, I still can't spell. Let's try this again. Okay, so I have the independent, and I have the dependent. Okay, well, let's take the example before where we had miles and we had gallons. Now, the thing you have to ask yourself is this, is which one depends on the other? Okay, which one can stand alone? Well, gallons can stand alone, so this would be my independent. And miles depends on gallons, because I can only go so far with the number of gallons I have. This can't stand alone because this depends on this. So this would be my dependent. Remember, so my independent is going to be my x variable, and my dependent is going to be my y variable. Okay? Because my y is always going to depend on what I do with my x. Now, this is really, really important that you understand these two concepts. If you don't, make sure this is one of the questions you're asking tomorrow in class. I'm going to show you one more problem. Okay, this one's a little different because now I'm working from the graph. So Andrea is a street artist in New Orleans in Louisiana. She draws caricatures, which are like those cartoon-like portraits of tourists. People have their portraits drawn and then come back later to pick them up from them. The graph below shows a relationship between the number of portraits she draws and the amount of hours she needs to draw the portraits. If we look down here, time spent is on my x-axis. This is my independent, okay, while the number of portraits drawn is my dependent, because this depends on this. You can't draw the portraits if you don't have the time. Okay, so the first thing that I think we should do is this. We probably need to write some ordered pairs. And the way I would do that is I would go and look at where the grid lines cross. So I'd write an ordered pair here. I write an ordered pair about this dot. I write an ordered pair about this dot. Okay. So I would have my first ordered pair is 2, 3. My second ordered pair is 4, 6. My third dot is 6, 9. Okay. Now, I need to find my constant. And what does this mean? That in 2 hours, she draws 3 portraits. Okay. So, remember my k. What do we say the k equals? It should equal y over x. So I'm going to go 3 over 2. If I reduce that down, well, that's in simplest form, but I can go and I can make it a mixed number if I want to, which is 1 and 1/2. 4, oh no, sorry, wrong way. 6 over 4 equals 1 and 1/2. And 9 over 6 equals 1 and 1/2. So these are all, this is all my k. This is because these are all the same. Here's my constant proportionality. So my equation y equals kx, my k is 1/2. And if I go over to 1 and I go up, this dot right here is at 1.5. So that would make sense. So y equals 1 and 1/2 x. Alright? Now, so that's my constant proportionality. So in this instance, it takes, in 1 hour, Andrew can make 1.5 portraits. Okay, and I could use this to determine, you know, in how many hours can she make 20 portraits, or in how many hours is it going to take her to draw 5 portraits. I can use this now as my baseline to go back and work with. And this is what we're going to be doing. Like I said, this is probably the most challenging lesson. So if you have questions, make sure you bring it to class and we'll have them in the discussion. I have one final slide. Okay, basically I just want to summarize everything. And basically that if a proportional relationship, if I describe it with an ordered pairs, if I give you some ordered pairs, that equation is going to be y equals kx, where k is my positive constant. And we call this k the constant proportionality. The constant proportionality is, we express it as the multiplicative relationship, where I'm multiplying back and forth between the x value and the y value. Okay? Make sure you fill out your WISC form and bring it to class. Like I said, I know this is challenging, but we'll get it worked on. Alright, I'll see you in class.